the unit we are supplying to Train 18 project, and what are all the features and few part of reliability, and finally about the cab air conditioner. All the topics: introduction of the system, and performance of a HVAC, maintenance, reliability, and cab HVAC unit brief. This is about basically why we need heating, ventilation, and air conditioning to any closed area. To give the human comfort, we have to maintain certain temperature and relative humidity, that is RH. To maintain this temperature and humidity, we should have a machine that is heating, ventilation, and air conditioning. So the air conditioning basically process cooling, dehumidification, heating, and air filtration. Here we will bring down the temperature or maintain the temperature if it is lower, and that's where cooling and dehumidification happens. Heating basically to maintain the temperature accurately, and above and all, air filtration is mandatory. Like any environment will have some sort of dust particles, so that's why air filtration is necessary. So this system basically, vapor compression freon system, which will have a compressor, condenser, evaporator, and other electrical motors, fans, and controls. Maybe some of the officers may be new to the to going to maintain the system. To give a brief idea, this is the schematic of working principle of the air conditioning system, air conditioning refrigeration system. In the picture, you can see this is the compressor, and this is the condenser where the heat rejects. Again, expansion device, evaporator coil. So here what happens, basically the compressor, this is the closed loop where the compressor which compress the low pressure gas to the high pressure gas. Whenever any gases are compressed from low pressure to high pressure, the heat is generated. To remove the heat, similar to the radiator, we have the condenser heat exchanger coil here, and it will have an axial fan to exhaust the heat. By that process, the hot gas, which is subcooled, and it become liquid when enter into the evaporator. This is how when the temperature lowers down, and the room air will be warmer, which is passed over the evaporator coil where the evaporation takes place. That's how we are getting the cooling inside the coach, and able to maintain the temperature and humidity. Basically, in evaporator, the heat is removed in the coach as well as the humidity. Yeah, so far, I've given a brief idea on basic of the refrigeration air conditioning system. Now we are going to talk about the specification of the RMP roof mounted unit we are giving. This is approximately 8 capacity, that is 29 kilowatt, and heating capacity is 9 kilowatt. And dimension of the unit is 2.5, 2.1, and zero point 0.5 meters is the dimension of the unit. And the fresh air quantity per HVAC unit, that is 645 cmh, and supply air volume, that is 600 cmh. Refrigerant used is R407C. This refrigerant is having a blend of three compounds, so handling should be proper. I'll cover more in detail in the maintenance. The unit weight is approximately 800 kg, the max, but we have achieved, in fact, 110 kg lesser than this. And the new feature here, this is a variable speed compressor is used, one compressor is used in this system to get to modulate the cooling capacity as well as optimizing the power consumption. And there is one fixed compressor. I'll cover more in detail on the coming slides how it is going to function compressor 1 and 2. And then condenser fan is fixed one, that is two condenser fans. Again, it is operated by 415 volt AC and 50 hertz and three phase. Again, supply fan is again it is a fixed speed and voltage 415 volt AC and 50 hertz.
Supply fan is for what purpose?
Supply fan, this is the air which supplies into the coach through the duct, sir. This is the
Supply fans means blower, na sir?
correct, sir. Blower, yeah, blower fan.
Basically, it sucks in the atmospheric air and feeds into the compressor.
No, 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 no. This is the supply. This is the blower fan, which is take the air from the coach, cool it, and again supply through the duct. As well as it also take a certain amount of fresh air from the fresh air provision
Okay.
given in the unit.
Yeah, through the duct. Okay, through the duct it will supply the air, the cooled air.
Yes, sir. Cooled air through the duct. Yeah.
Okay, fine. Please
Yes,
go
sir.
ahead.
Yeah. Thank you. Thank you. Thank you, sir. So far we discussed about the basics of the HVAC and the specification of the HVAC. And this is the components illustration of the RMPU. What are all the components? When we talk about the LHP RMPU, so here a few new advanced featured components are given here. So I'll cover one by one. So the serial number one is a compressor, vertical compressor. So this is the vertical compressor. And 1A, this is a horizontal compressor. And 2 is these are all the mounting brackets in the structure. And 3 is the condenser fans. This is the two axial fans which is fixed over the shaft, extended motor with the extended shaft. And these are all the drain pipes you can see here. These are all the two drain pipes. From the evaporator, while during cooling process, the water will be condensed from the evaporator, which is routed through the drain pipe. And from this drain pipe, there is external piping will be connected, and it will be provided at the end of the coach so that the water can go directly at the floor. Then this serial number 5 is condenser coil. This is the condenser coil, two heat exchanger coil, which I shown in the first in principle refrigeration principle. I have shown the condenser heat exchanger, basically to take the ambient air in and rejects the heats outside. There are two accumulators here. This is the two accumulator which can prevent liquid flooding. And there are two fresh air dampers. This is one damper, and here the other one. They're both the side having two fresh air dampers. So we can discuss more in detail in the coming slides. What is the function of these dampers to take the fresh air? And there are return air filters, two filters. This is one filter. The other one is this filter. This is the return air. This is basically mixed air chamber. The mixed air which passes through the return air filter, and again cold air supplied to the coach through the duct. There are two evaporator coils here placed on both sides of the blower fan. And blower motor, this is a double shaft blower motor. Number 12 is OHP, overheat protection for the heater. And there is a small, and the supplier of the fan, there is a small duct placed inside the unit. This is the new future. First in Indian Railway, we are introducing. This is variable frequency drive. That is number 14. This will.
क्वेश्चन देखा है आज मैं डेली ना एक क्वेश्चन दे रहा हूँ हमें किया था ये क्या काम है फॉरवर्ड करना कह रहे मुझे डायरेक्ट मैं डायरेक्ट फोन कर रहा हूँ तो टॉपिक है ये Refrigeration.
Please switch off your microphone. All are requested.
मैं काम करना वाला ना.
Yeah, this is a variable frequency drive, variable voltage, variable frequency drive, which drives this compressor, horizontal compressor, to modulate the cooling capacity. And the other one is emergency inverter. These inverters are well placed in metro coaches earlier and now also. But Indian Railway, this is the first time we are placing emergency inverter. In case of 415 volt power failure, this emergency inverter will be able to supply the minimum air quantity as per the standard, so that there won't be any suffocation inside the coach. Even though there is no cooling, certain amount of fresh air will be supplied to avoid any suffocation inside the coach. And this fresh air which takes from the bottom passes through the two fresh air filters, that is point number 16 mentioned here, this one. This is brief about the parts in the unit. So I'm moving to the next slide. If any queries, please raise. So this is to have more clarity. This is the bottom view of the unit, which the fresh air intakes. And other than the condensed water drain hole, in condenser area also, in rainy season, water has to drain. There are four drain holes. Inside view gives some idea about the mountings. There are four mountings each side, so 8 mountings per unit. And in Train 18 HVAC, the connectors, power and control connectors in one side. All the three connectors, quick connectors, are placed in one side of the unit. Now I'm going to explain about the components what we are using in the unit. So this is the new technology, as I briefed, triple VF drive, variable frequency, variable speed compressor is being used in this system to give a better energy saving. And so it is really giving a very good energy saving over a period of time. As per the lab simulation, definitely it is giving a very good energy saving. And we will also uh, do the study in the field in the first train itself, and take the actual energy savings. Whereas
How,
yeah.
pardon, how exactly it is doing the energy saving? Could you just elaborate on this?
Sure, sir. So basically, this will modulate the cooling capacity by varying the speed of the compressor, so that the refrigerant flow will be less. So by reducing the speed and refrigerant flow reduction, the load on the motor will be reduced. That's how the power consumption in turn it will reduce.
So
So
it
if
will
our
sense. Yeah.
Yeah, initially both the compressor will run to pull down the temperature inside the coach. Once the temperature reaches, we may not require to run both the compressor to again to maintain that small delta T, that is the temperature difference in the return air and the supply air. Say for example, inside the temperature set to 25 degree, so initial only we need more power, cooling power, to pull down the temperature. So after that only makeup cooling is required, since these trains are all long distance trains, and there won't be any very high passenger load. It is fixed load only. So only thing is, based on the ambient, the second compressor will switch on. Otherwise, very minimum cooling requirement is there. That's why the compressor will run at lower frequency. So whenever we reduce the voltage and frequency proportionally down, so the power consumption will be reduced. Say for example, this compressor runs at 8 ampere or 7 ampere or 11 ampere. So when it runs at lower frequency and lower voltage, the power consumption, the current will be less current will be taken. So that's how we can able to save energy. So this type of technology has been used widely and for a long time in commercial application. There we say VRF system, variable refrigerant flow system. So now by implementing this, we hope definitely Indian Railway will have a good energy saving.
Achha. And just two things. So you do have the temperature sensors inside the compartment, and by the delta T only, I mean, all the modulation is being done.
Yeah, basically there are return air temperature sensor, and this system is operating through PID control. So based on the return air temperature and the temperature difference, set temperature versus return air temperature. So based on that,
Hmm.
the system, the compressor speed will vary.
What is that
Okay.
hermetically sealed means what?
This compressor hermetically sealed. This is, you can see the black shell dome, which is totally sealed, hermetically sealed. Hermetically means there is no external device connected. This one, everything is hermetically sealed and coupled inside the this shell. There are many types of compressor. There are many types of compressor. This is a hermetically sealed scroll compressor. There are even open type compressors. Only the mechanism with the extended shaft will be there, and the motors can be coupled externally. And even semi-hermetic compressors also available. So those are all being used in refrigeration systems for negative applications and all.
Okay.
Yeah.
How much is the mixing of the air? Like how much is the fresh air and how much is the return air? I mean, is mixed.
Yes,
Or
sir. As I reviewed, the 645 cmh is the fresh air supplied through one unit.
okay. No, I mean to say the same air is being recirculated or fresh
Yeah,
air.
partially. Yeah, 645 out of 400 4400 cmh, 645 cmh fresh air will be fed always. The remaining air is recirculated inside the coach.
Acha. And the one last thing that how this triple VF technology is basically, matlab, is it not employed in other compressors in Indian Railways, or is it for the first time that this triple F technology is used in compressors?
Yes, sir. Yeah. So far, LHB has been launched more than 15 years. So far, fixed compressor is being used. So
Mhm.
since the compressor manufacturer recently developed the suitable variable frequency compressor for transport application, so
Mhm.
that's how we are taking the benefit to save the energy. This is the
Yeah,
first time.
yeah, but you are telling that when the temperature difference is less, then the smaller compressor is turned off. So that is one way of saving the energy. But how this triple VF is actually being utilized in conserving the energy? Could you just elaborate on that point? The triple VF technology, how I mean that is translating into saving of the energy.
Yes, sir. Say, for example, the cooling capacity of the unit is 8 TR, considering the maximum ambient, that is 50 degree.
Hmm.
So the worst case, the 50-degree ambient internal heat load will be higher.
Hmm.
So considering that, we are designing this system,
Hmm.
whereas it will not be the condition all the time. That is the worst case, since for railway it is a moving application. The machine is designed for the worst case.
Hmm.
So,
Yes.
whenever the coach, empty coaches comes, maybe in summer, the internal temperature will be higher. That time,
Hmm.
more cooling power required. Both the compressor will work.
Hmm.
Once the cooling reaches to the set point, the one compressor will be off. The other compressor will work based on the PID control. That is the set temperature versus the return air temperature. In
Hmm.
that case, what will happen? There is no much cooling load. So based on the PID control, the frequency of the compressor will be reduced. So it
Okay.
started from 50 hertz, it will go up to 35 hertz. So
Okay.
whenever it will step by step, it will slowly reduce based on the temperature difference, set temperature versus
Hmm.
return air temperature. If the temperature difference is more than one, so it
Hmm.
will run at 50 hertz, one compressor. If the set temperature is less than 1.5, slowly, step by step, the compressor will reduce the frequency, variable frequency drive will reduce the output frequency and voltage, and run the compressor at lower speed. So that is how we are going to give, basically how much cooling is required, that much it is going to give. It will not give excess cooling.
Hmm. So reducing the frequency, the voltage will also be reduced.
Yeah, proportionally it has to. That's
Okay.
how the variable voltage also will, voltage and frequency both has to proportionally reduce. We cannot reduce only voltage or only frequency.
Okay. So in that way, like the power consumption or power requirement will be reduced.
Absolutely, sir. Yes, sir.
Okay.
Yeah.
Okay. Fine. 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 May please go ahead.
Right, sir. Right, sir.
Excuse me, sir.
Yes, sir.
Sir, do we have the same system in the existing rake? Like the two rakes we have, do we have the same system in these two rakes?
No, initially it was a fixed compressor. It is the fixed compressors. So since actually this technology was not, the suitable compressor was not there at time, though now it is available. So we want to use that. That is how RDSO also want to use this compressor, and it is really helpful for energy saving.
But
Uh,
the compressor we have in the existing rake is of Amit engineers, right?
No, sir. We have not supplied in the first rack, but we have supplied widely last 15 years, more than near about 2 decades. We supplied for LHP coaches.
Okay,
But
that means you will be like presenting this in the new upcoming rakes.
yeah, this 44 train set, we are going to, we already supplied some samples, so we will be supplying the complete quantities.
Okay, like means
well,
rake 1 and rake 2 don't have this Amit engineer systems, they have something else. But I want to address a problem that we are facing while maintaining the T18. This is about
Yes.
the uneven cooling in the rake. Like for example, the coach which have the TC, like which have the pantograph on it, that has given a curve inside. So
Yes, sir.
because of that particular curve, now there is a kind of uneven cooling. Means like one passenger will be saying that it is too much cool, and another passenger will say like it is very bit hot. That is in fact, like this is actually in the inside the coach. So how you will address all those things in the upcoming rakes? And number two, there was one more problem that when it is cool inside, so there was water dripping from the ducts inside, like the AC ducts we have in the rake, the water
Yes.
was dripping, and that water was like sometimes a mug full of water on the particular passenger when at the time of acceleration and deceleration. So how we will address these two problems in the upcoming rakes?
Sir, thank you for your very useful feedback. Definitely, yes, we also done some taken some feedback from the existing rack. So that's why one is the duct sweating happens due to uh, there is a improper insulation, or insulation might be damaged. So other than that, to ensure there is a proper air circulation, we have done a detailed design analysis, and we have designed the fan. So it will have a much more airflow. The previous one really we don't know, but we have given slightly
Yes.
higher airflow to give a better air circulation, and we believe and hope this will solve that issue. And definitely in the first train we completely do the study. Yes, yeah, and if any thing required, we will definitely address.
Sir, this PVVF voltage
Yes,
and
sir.
frequency, either any one can be reduced, no, sir? Is it uh, both voltage and frequency at a time will be reduced?
Yes, sir. Proportionally, it has to be reduced. Theoretically, there is a, formula. We reduce only the voltage and not the frequency. The motor current will not be balanced. So that's why the motor will get heated up. That's why any triple VF system, the voltage and frequency both are proportionally reduced. But however, the fixed compressor also having some tolerance. But the triple VF compressor is designed in such a way we have to reduce voltage and frequency both.
Okay.
क्या हो गया यार? अरे यार अभी what is the difference between this existing in the existing rate the compressor being used and what you are proposed to be supplied? You are going to supply in the next deck? I mean, what's the difference in the existing deck and the proposed deck as far as this compressor is concerned?
A compressor, it is a variable frequency. You can see there is one compressor horizontally placed, that is a variable speed compressor. The other one is a vertical compressor. That is a fixed speed compressor, the vertical one. In previous coach, both the compressor are fixed speed.
Okay, okay, that's the only difference. Okay,
That is the
right.
only difference. Yeah.
And what about this? These are not oil-free compressors as the other compressors are being used in T-Train 18. Or
No, oil-free compressor is used in brake system, sir. Whereas here, this is having oil circulated lubrication is there inside the compressor. Whereas in horizontal compressor, there is a additional oil pump also available since it is horizontal. So to have the proper lubrication to the mechanism, there is a small inbuilt oil pump is available in this. Whereas in vertical, that is oil lubrication happens due to centrifugal force. Whereas in horizontal, it is a oil compressor. Both are oil compressors. There is no oil-free compressor.
and what is the PUH periodicity for these cylinders?
Sorry, sir.
What is the PUH periodicity? Like when it's to be overhauled or to be removed? I mean, what is the life or period or this overhauling cycle? Like what is the periodicity of that?
Sir, minimum yeah, 8 years or even more also, our units are running in the field. In the vertical scroll, we have been supplied to Indian Railways in LHB coaches. And above and all, for proper maintenance, the reliability will increase, sir. The life of the compressor will increase.
So anything is to be done during this 8 years period, like some top up or something, or it will remain okay, like without any failure. It will be attended only at the time of any particular failure only.
Yeah, at the time of any failure only we have to do, sir.
Otherwise, nothing to do in 8 years.
No, no,
At
yes,
this.
sir. Yes, sir.
Okay, fine. Yes, please go ahead.
What about trip
What is
maintenance and like regular weekly maintenance?
No, for compressor, there is no particular maintenance, sir. Like there is a periodic and preventive maintenance we will give in the manual. Basically, we have to check the proper insulations are in place and the terminals are properly fastened and the terminal covers are properly tightened. These things we have to check on a periodic check.
Sir, what is the coolant used, sir?
Now, this is a refrigerant used R407C. That is the refrigerant used.
Yes, sir. Pardon?
407C. 40R40. R stands for refrigerant and 407C is the manufacturer's code. Internationally, the same code is being used. R407C.
407C.
Yes, sir.
Is this completely make in India kind of thing, or we are also imported some of the parts from like different countries?
No, basically this compressor we don't have any manufacturing in India. This is again imported by every OEM. Yes, sir.
So, what is the OEM for this case? Who is the OEM?
This, this is Emerson, sir. Emerson is the manufacturer.
Emerson is the. So, you are the authorized dealer.
No, no, we are OEM. They directly supply to us. We don't take through dealers. We Emerson directly supply to the OEMs. We are HVAC OEM. They supply directly to us.
Okay.
Sir, 407C, has it have any chemical name for it? Only R407C. Any chemical name for that?
Sir, dichlorofluoromethane. I'll just exactly. I'm not remembering now. I will share with you.
Okay, sir. Okay.
It won't be chloro because this chlorine affects the ozone layer. It might be some advanced version of it.
No, no, dichlorofluoromethane, sir. 1 second, I will tell you.
If it is chloro, then chlorine is something which depletes the ozone layer. So that is an old story. Like presently, I mean, we don't use that composition. Yeah, you can see the name maybe later on.
Yeah,
If you,
okay, sir. I will share before closing that.
yes,
Yeah, I
yes, yes.
have the
Yeah,
information.
because
I'm just moving to the next
next
slide.
slide. Yeah.
Here, actually, there are new features or new components, advanced technology components have been added on performance wise of the system as well as the safety aspect of the system. So here I have shown the pictures where the new components are added in the HVAC system. Just the discharge line check valve, particularly provided for horizontal compressor to prevent any liquid flat back to the discharge head. And the 8 point number 8 is air differential pressure switch. This has been provided to give an indication is there a filter blockage, fresh air filter blockage is more than 70 or 80 pascal. That time this will give an indication so that maintenance staff can do the cleaning the filter so that we can get a proper fresh air as well as the better cooling. And safety point, there is a fresh air smoke detector. This is the smoke detector provided. In case outside is there any smoke, this will detect. And there is a CO2 sensor. If inside the coach the CO2 level increases, the CO2 sensor will sense, and certain logic has been provided. And return air damper actuator, fresh air damper actuator, basically in case of emergency the return air will close and totally the fresh air will be fed into the coach. And in case of smoke outside also, the fresh air damper will close. These are all the main new components added. And other than that, from refrigeration side, this is a triple VF drive compressor, variable speed compressor, and there is an emergency inverter. And microprocessor controller is the to have the additional components. The controller has been upgraded.
How does this emergency converter runs? I mean, it gets the supply, the emergency inverter from where it.
Emergency, when in case of 415 volt AC failure, the power supply from the battery is supplied to the inverter. The
Mhm.
inverter again convert the input voltage to output to AC voltage, DC to AC voltage, and run the blower to give a minimum sufficient of air uh,
Yeah.
in case of any power failure.
It runs on 110 DC.
No, the input will be 110 volt DC, output
Yes.
will be somewhere around 300 volt AC.
No, that's okay. The 110 volt DC is the input voltage, na?
Yes, input voltage from the battery.
Battery. Okay, fine.
Sir, what is the horizontal scroll compressor? VVF drive for?
Yeah, basically there are two compressor. One is the vertical compressor,
Okay.
that is a fixed speed compressor, and
Yeah.
horizontal. There is one more horizontal compressor that is actually variable speed compressor.
Oh, horizontal
The
is variable speed, huh?
no, horizontally placed. It is horizontally placed. Vertical is it is straight. The horizontal is it will be flat.
It is horizontal because of the space constraint. Otherwise, the ideal would be the vertical one.
No, actually, to this capacity, currently Emerson don't have any vertical speed compressor. That is how this is the availability. Based on the availability, we have given horizontal compressors.
So, what is the most suitable, the vertical one or horizontal one, as far as the, I mean, displacement is concerned, or its durability or maintenance is concerned? Uh,
Mm, there is only horizontal, it will occupy less space, but once Emerson comes out with vertical, also we can provide in future projects with vertical. But horizontal, yes, definitely it will occupy less space, height
Okay,
wise.
okay, okay, fine. Yes.
Yes, sir.
GBC means what, sir? GBC shut off valve.
Yes, sir. Earlier there were no hand shut off wall. So this is a GBC it is a compact wall which can be operated by a spanner, basically to pump down the system. Earlier you might have seen the wall with the bigger handle. Danfoss has come out with a compact small wall, that is a GBC nomenclature they have given. So
No,
it is
GBC,
a shut off wall, normal shut off wall. It is a compact one.
no, GBC means any expansion, GBC.
Yeah, I'll note down, sir. Let me find out from the OEM the
Okay, sir.
nomenclature they have given. Yeah,
Okay.
Okay.
Yeah. Next slide, please.
yeah. Basically, this is how the schematic, how the RMP is controlled from the controller. Basically, the RMPU, this is just basic schematic. The RMPU gives the digital inputs to the controller and analog inputs from the sensors. And digital output is given to the electric cubicle. From there, all the motors and controls are operated. And it is having a, HVAC. This is what how the controller is integrated with the RMPU, and the controller is placed in the switchboard cabinet similar to LHV coach.
Okay.
So now we are moving to the function of the HVAC, basically the controller. What are all the modes available? Yeah, the first one is the cooling mode. In cooling mode, constant heat transfer on evaporator side from primary refrigerant to secondary air will takes place to excess sensible and latent heat inside the coach to remove the excess amount of sensible and latent heat, basically. And in condenser side, sensible heat rejection will takes place to keep the system balanced. And the cooling capacity is 28 kilowatt. Input power is for 15 volt, 50 hertz, 110. Basically, in cooling mode, what is the function? We'll see here. Basically, if the difference of return air temperature and set temperature, that is, return air temperature minus set temperature is negative, only blower fan will work. And if the difference of the return air temperature and set temperature, return air, that is return air minus the set temperature, or greater than 1 or 2 degrees Celsius, then condenser fans and compressors will work till it reaches the set temperature. Initially, what will happen? The controller will take the temperature, get the feedback from the temperature sensor. If the set temperature, the temperature inside the coach is lesser than equal to 1, then only the compressor will start working. Otherwise, if suppose if the ambient as well as the inside the coach is less than 25 or 23 the set temperature, then only the blower will work. It will not allow the compressor or condenser fan to work. So if the difference of return air temperature and the set temperature, that is return air temperature minus set temperature greater than 2 degrees Celsius, both compressor and condenser fan will run till the temperature reaches the set temperature. Once the temperature reaches, then the set temperature will be maintained within plus or minus 1 to 2 degrees Celsius with the triple V of compressor by varying its duty cycle using the proportional integral derivative, that is PID controls. The control loop feed mechanism to control the temperature by varying the frequency of the compressor as explained earlier from 35 to 50 hertz as required.
So both the DC and the AC, both inputs are coming, sir. 415 volt AC and 110 volt.
Yeah, both is required. Like in fact, all the switch gears and all it is operated by 110 volt DC.
So 415 is only for compressor.
Yeah, 415 only for the motors. That is the compressor
motor.
motors, condenser motors, and blower motor.
So all
What
the
is this?
other control circuit is 110 volts.
110 volt. And there is the controller is a 24 volt DC. There is a DC power supply.
What is PID? Proportional integral derivative?
Yeah, this is basically for logic for the variable frequency drives. That is the set temperature versus the retainer temperature.
So by varying the frequency, the voltage is increased and the power of the compressor is basically increased to, I mean, again make it to reach to the set point.
Correct,
This,
correct. Yeah.
okay, okay, fine.
So far we discussed about cooling mode and heating mode. Basically, this is having the electric heater of 9 kilowatt to maintain the temperature if the outside ambient is lower, and inside the coach it will maintain 17 to 21 degrees Celsius in winter. Here the logic function has been given. If the difference of the set temperature and retainer temperature, that is set temperature minus retainer temperature, less than equal to 1, heater will on for 5 seconds and off for 55 seconds. So if the difference of the set temperature and the retainer temperature, that is the set temperature minus the retainer temperature, greater than 1 to 3 degrees Celsius, heater will on for 30 seconds and off for 30 seconds. So the third one is the if the set temperature minus retainer temperature greater than 3 degree, heater will on for 55 seconds and off for 5 seconds.
But in case of heating of the air, its relative humidity also changes. So what do you do to maintain the relative humidity of the air to that limit, or you don't bother about the RH in case of heating the air in winters?
Yeah, in winter there is no such a system to maintain the humidity. That is why we don't want to heat immediately and continuously. There is a sequence and logic is being given here. So it will heat the air, and that's how it will not work continuously. Heater will not work continuously, so that able to maintain the uh, a possible humidity inside the coach.
Okay. Okay.
Sir, if there is a requirement of some logic update as per the requirement in railways, so you will be the person who will be doing configuration.
Sir, your voice is not audible, sir. There is an echo from backside.
Sir, you are configuring the HVAC unit.
Correct,
Maybe
sir.
Okay, sir.
No.
Yes,
Sir,
sir. Please.
this sir, basically this HVAC means what is it, sir? High voltage, yeah?
No, sir. From the first slide itself, I said heating, ventilation, and air conditioning.
Okay, thank you.
Yeah. In dehumidification mode, basically.
First side la sonara. Then some.
Yeah, no problem, sir. I can repeat once again. Please feel free to ask questions, sir. No issues.
Sir,
Yeah.
I was asking one thing. Let's suppose if there is requirement to update that logic for passenger comfort in railways as per practical requirements, then is there any possibility for I would say reconfiguration in this system, or this will remain constant throughout the race?
Sir, currently the logic which has been approved or guided by RDSO, we have given the logic, Yes, in future, if any temperature control or set temperature related things, if we have to change, then yes, if Indian Railway wish to do that, and if we get in a proper channel, yes, we can do so.
Okay, sir. Thank you.
Yes, sir. In dehumidification mode, basically the system will maintain the RH relative humidity less than 60% inside the coach. If the relativity of the return is more than 60%, then the temperature is below cooling set point. During this process, VFD compressor and heater shall be on, while another compressor and one condenser fan will be off position. The heater will be switched off after 3 minutes and will remain off for further 5 minutes.
So
So
by
in this case, to if the relative humidity inside the coach goes more than 60%, so the one compressor will be continuously working. By running the compressor continuously, the temperature, sensible temperature will come down. So to maintain the desired temperature inside, the heater will be parallelly kept on for 3 minutes and off for 5 minutes. That is how we could able to precisely maintain a 60% RH as well as the temperature.
so by heating the air, you are basically, I mean, decreasing the relative humidity from 60%
No,
to.
no, sir. Relative humidity we are doing through dehumidification.
How
Whenever
you are
the
doing that?
dehumidification, but by doing the dehumidification, by any chance, if the train goes to coastal areas, if the relative humidity goes more than 60%, so one variable frequency compressor will on and heaters will on and off in sequence, so that when running continuously, uh, the compressor, the cooling will be more and temperature will come down less than the set point. To avoid that, to maintain the desired set temperature, the heater will on and off.
Yeah, I got it. I got it. By cooling, I mean the this vapor, I mean the water molecules will condense, but at the same time the temperature also will get down to. So again, to maintain the temperature, you are, I mean, heating the air.
Correct, sir. That is absolutely right. Yeah.
Okay, fine. And what is the process if the air is less humidified? Then how you will increase the humidity?
No, that's what if the set if the 60% humidity has reached, there is a hygrostat inside the unit. So it sends that and it will switch off the heaters, and when the temperature reaches within that time, immediately it will switch off the compressor also.
And suppose if the relative humidity is 40% or 30%, then
That time we cannot do anything, sir. Like it depends on the temperature. If the temperature is higher, then the unit will run. If the temperature is lower, then the compressor will not come on, or the heater also will not come on until below 17 degrees Celsius.
okay, so it's mainly the temperature control. Okay.
Yeah, so here actually basically to add any water particles, obviously whenever the unit is working, the supply air temperature will be higher humidity. So that is how it will try to maintain the humidity up to 60%. Normally the refrigeration system, whenever it runs, the supply air temperature and the supply air RH will be higher.
So
So
the
that is
high
how
gross,
if lower humidity, it will try to increase the humidity and balance and try to maintain the 60% RH.
so this hygrostat and
Yes, sir.
is it different from the hygrometer, which
Now
to measure the
hygrometer we can able to see the reading. This
okay.
hygrostat basically it sends the percentage of RH and give the signal to the compressor and heater through controller.
Oh, it is a controller.
Yeah, it is a control. But it will
Uh,
give only signal. It will give only signal to the controller. controller will then give command to the compressor and heater.
Sir, once again, if you will explain how switching on heater
Sure.
can help to control the RH.
So if the RH goes more than 60%, so to dehumidify, we have to run the cooling system for more time. So for by running more time, the set temperature, the cooling inside the temperature will go below the set point. So to avoid that, we have the heater will on for some time 3 minutes and will off for 5 minutes until it reaches the RH 60%.
Sir, this is that you are explaining about the logic functions, but I am
Correct.
asking how by switching on heater, humidity can be controlled. Relative humidity can be controlled.
No, heater is not controlling the humidity. Sir, once again I will explain. So heater is basically to maintain the temperature. The temperature should not go less than the set point or less than the desired condition for the human comfort. The dehumidification, by dehumidification and running the refrigeration system, we could able to bring down the RH. Say for example, if the humidity is very high in some areas, we have to run the refrigeration system for more time compared to the normal lower RH condition. So in that case, the temperature will come down. To maintain the desired or human comfort temperature, the heater will on and off. You got it, sir?
Sir, if I have kept the set point within on higher side, let it be on 25 degrees centigrade.
Correct.
Then even then heaters are switched on in dehumidification mode. But at 25 degree, it's according to human comfort. 23 to 25 is the human comfort as per ASHRAE.
Yeah, that's what. If the temperature is maintaining 25, it will not on. Again, it is depends on the humidity. Even though if we see in North India, like there is not much humidity, even though the temperature is high, we could able to manage. Whereas in coastal areas, even the temperature also 35 or 37, the humidity will be high. The human will feel more uncomfort. So that is how here, particularly in this stage, even the 25 it will maintain, but the heater will on for some time, but the temperature will not go more than 26. So that is how it is able to control the RH and as well as temperature.
Sir, I think that by increasing temperature, the saturation point of air is enhanced. That is, moisture carrying capacity of that air is enhanced. I think it is linked like that. Am I right?
Yeah.
And when the moisture carrying capacity of a confined space is enhanced, the more moisture can be carried to the evaporator coils, which will condense the moisture and throw it out in the out from the internal confined space.
Yeah, it is not continuously on, sir. If it is continuously on, as you said, yes, the temperature will go higher. Yes, obviously, whenever the air is very dry, it will tend to, if the atmosphere outside is more humid, so it will tend to absorb more moisture. That's why, the heater will not be on and off continuously. It will not on continuously. So practically, this has been proven for many years, and even we can see in the coming trains also. These logics based on the feedback from the previous train experience, this logic has been implemented. Concept. Yes, sir. Can we move on to next slide?
Yes.
Yes, carry on.
Yes, sir. This emergency ventilation mode. In emergency ventilation mode, basically, if 415 volt input power supply fails, the 110 volt DC on to run the blower fan through dedicated inbuilt inverter in the HVAC. And it will ensure that minimum fresh air will be fed into the coach per unit 645 cmh. This is again placed inside the HVAC unit with both the variable frequency drive and the emergency inverter is placed inside the unit. In case of controller failure, the manual cooling mode, there is one option in the switchboard cabinet. So there is a rotary switch which can be put into the manual mode so that the unit will run in the cooling mode. This is a brief about the control logic. Basically, the controller read the parameters of pressure, temperature, and smoke, as well as CO2 inside the coach. And the controller shall perform the following function concerning control and regulation of air conditioning system to maintain the desired comfort condition inside the coach. And this train is having a additional new feature, that is TCMS. The fault and all will be uh, displayed in the TCMS. This controller is having those features. This is about a brief about the cooling set point and the heating set point, and this is broadly followed in even LHV coaches. And there are safety devices under various operating mode such as LP, HP, and control pressure switch, TOP, and OHP. System safety components is a high pressure safety control switch, low pressure safety control switch. If the head pressure goes beyond 425 psig, the pressure switch, mechanical pressure switch, will open and give a false signal and ensure the compressor will not run beyond this designed pressure. Similarly, low pressure, if the system suction pressure goes below the 35 psig, again the pressure mechanical pressure switch will cut off the compressor. Control pressure switch, if the ambient is low, less than 275, one fan will come into off condition. And again, the temperature pressure rises. Again, the mechanical switch will open. I'll allow the second fan will on. The motors which have a thermal overload protections and heaters have overheat protections. And the second level is 85 degrees Celsius. The first level is 65 degrees Celsius, and the third level is 130 degrees Celsius. The switchboard cabinet, which is having a earth leakage fault protection, earth leakage protection system. As I briefed earlier, the smoke sensor, if there is a smoke ingress from outside the coach, so the smoke sensor will sense and shut down the entire system for a few minutes and close the fresh air fully and run only the uh, cooling system by opening only return air. And there will be a fault signal also generated to the driver desk. MPCB and contactors also have feedback given to the controller if any fault. Above all, this unit is having a UV lamp to purify the air which comes into the return air path. So this UV lamp is a newly added feature in railway HVAC. So whenever the return air comes, this pass through the UV lamp, and then over a period of time, inside the coach, the air is purified, bacteria are killed.
Is it there in the existing rack?
Existing, it is not there, sir.
Acha, acha. And what is the benefit in case of a smoke detection by closing the fresh air supply? I mean,
If there is a smoke outside, and if keep feeding the smoke is when we take the fresh air, the smoke also get into the coach and the CO2 level increase, and the customer passengers will feel discomfort and also the safety aspect. That's why there is a very sensitive smoke detector. It will sense and close the fresh air.
it
This is
will,
the outside smoke detector.
so it's outside smoke. It's not inside the coach.
Inside the coach also, we have given the complete smoke detection system that is separately built into the coach, inside the coach.
So it is proposed for inside the coach. It is
Yeah,
proposed.
we are. That is a different system. It is not a part of HVAC. We are also supplying those system to this train eating project.
Is it there in the existing rack or inside the coach? It is not available as far as I know in the existing rack. Maybe in the future racks.
Existing, I will have to check, sir. I really not aware. I'll have to check. But in 44 trains, that yes, it was there in the specification, and
Yeah, in
we have.
future trains it will be there. In future trains it will be there.
Yes, future train it will be there, sir. So there are all three temperature sensors: return air, supply air, as well as the fresh air. Supply air temperature to ensure the temperature goes more than 85, it will switch off the heaters, and if the temperature goes below 5 degrees, then it will switch off the compressors, so that to protect the any heat or cold shock inside the coach. This is a fresh air, that is ambient temperature sensor, supply air temperature sensor, and hygrostat we discussed. This is also placed inside the unit, and air pressure differential switch, again it is placed inside the unit. So in one coach there will be one RMPU control which is connected to TCMS through RS485 communication. All the fault in RMPU control unit, inverter, triple VF drive are routed to TCMS through RS485 command by RMPU control unit. This is just a brief schematic of the inverter drive. triple VF drive system. Yes, sir. So far we covered about the basic of air conditioning system and what is the specification of the air conditioning system we are supplying to this project, and what are all the components and functions of the controller and at the component level. So now we are coming into maintenance of the HVAC unit. Here maintenance, basically there are two things. It has been maintained, and similarly here also the return air filter and fresh air filter, as per these guidelines, air filter cleaning in 2 weeks, 4 weeks and 24 weeks, and replaces at 18 and 36 months, or 6 to 12 lakhs respectively, whichever is earlier. And evaporator coils, these are all the heat exchangers which takes the air in and
सर फिल्टर क्लीनिंग को तो अकॉर्डिंग टू वेदर चेंज कर सकते हैं ना, जैसे राजस्थान में तो बहुत ज्यादा हवा भी चलेगी, आंधी चलेंगी, तो उसकी वजह से गंदे ज्यादा होंगे ना।
सर इसलिए इसमें एक्चुअली प्रेशर डिफरेंशियल स्विच भी है सर, सो वो इंडिकेशन दे देगा, बेस्ड ऑन दैट वो क्लीन करना पड़ेगा सर।
क्योंकि इन मेट्रो वी आर क्लीनिंग in a week during summer season and in 2 week in winter season.
Sorry, sir. Can you repeat your question?
So फिल्टर क्लीनिंग जो है
जी,
इसको हम 2 वीक में करेंगे या अकॉर्डिंग टू जो वेदर जो जिस तरह का है, जहाँ कई जगह आंधियाँ चलती हैं, कई जगह डस्ट ज्यादा उड़ेगी, कई जगह कम है, तो उसके अकॉर्डिंग ये चेंज हो जाना चाहिए मेरे ख्याल से।
सर ये वो 2 वीक्स इज द 2 वीक का मिनिमम रिक्वायरमेंट है। सपोज वो हम प्रैक्टिकली अभी ये ट्रेन स्पीड भी ज़्यादा है, इसलिए हमने एयर प्रेशर डिफरेंशियल स्विच भी दिया हुआ है। सो इन केस रिक्वायर्ड देयर विल बी इंडिकेशन टू क्लीन द फिल्टर, फॉल्ट यहाँ होगा, सो
डिपेंडिंग अपॉन द वेदर सिचुएशन इन पर्टिकुलर एरिया।
हाँ 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 सर,
ठीक है।
सो कॉइल्स हीट एक्सचेंजर्स हैं, इसमें एवापोरेटर कॉइल एंड कंडेंसर कॉइल्स हैं, वो ईयरली वंस क्लीनिंग करना पड़ेगा इसको। एंड सिमिलरली स्मोक डिटेक्टर आल्सो टू बी क्लीन्ड एंड चेक्ड फ्रीक्वेंटली और पीरियडिकली।
सर स्मोक सेंसर सिर्फ कैब पे डीटीसी वाले पे लगे, सभी में लगे हैं?
एक एक यूनिट में एक स्मोक सेंसर है,
वन स्मोक सेंसर इन ईच यूनिट,
हर यूनिट पे एक स्मोक सेंसर है।
यस।
A few brief about reliability, sir. Maintenance and engineering managers face challenges related to operating of the HVAC system in operation. Among the demands, reliability, energy saving, indoor air quality, and occupant comfort and control plays vital role. Since so to improve upon the reliability characteristics of the system, in-depth qualitative analysis of all HVAC units is carried out using root cause analysis. This is basically about the reliability and failure mode and FMECA, and this is something theoretical, this RPN number. So if the reliable system will reduce the risk of failure, improving indoor air quality and thermal comfort, handling an increased load, improving energy efficiency, and meeting new regulatory requirements.
Just go to the previous slide.
Yes, sir.
Yeah. Who is doing all these analysis, root cause analysis, FMECA and RPN number? Who is doing that?
No, reliability, basically the failure mode effective analysis, FEMICA, we do during the design stage. So So root cause like once the unit has been given in the field, so based on the if any failures that will be recorded and we do the root cause analysis.
And you also calculating this RPN number?
No, RPN number basically, a risk priority number. This is used in the calculation actually, based on the number of failures and based on the population of the system, population of the unit and the components.
So who is doing this calculation?
Yeah, we do. This is a brief about the reliability of the product. Reliability means what I have briefed here. We do, yes, in our other projects also.
Is it something like you collect the data, your failure, and on the basis of that, periodically you are doing these analysis? I mean,
Yes, yes.
what is the methodology? Or SED has to do anything with any of these this failure mode analysis? I mean, the maintenance side has to do something, or
No,
it's
maintenance basically they log the faults and failures. So definitely we our service team be in touch with them, and they are collecting those data, and it will be communicated to the HO, and we do see the how much is the MTBF and all mean time between failure.
they are collecting the data, or it is already, I mean, logged in the system?
Yeah, log also there is a limitation. So on a monthly basis, on a daily basis, where whatever fault comes, it is logged in every depot or shed workshops. So our teams are there all over India. They collect the data and it has been communicated to us. Yeah, based on that, if any corrective action required, we do based on that.
So what has been the experience of your analysis with these kind of failure mode analysis? Like, have you achieved something or made some modifications?
Yeah, based on the previous units, whatever running, like in fact, LHB and all, it's not compared to so much of components in this system. So yes, based on that only, there are improvements done in LHB coaches, LHB RMPUs. Yeah, yeah.
Achha, so you are doing it for LHB also, or only for this Train 18?
Sorry, sir?
You are doing it for LHB also, or doing it only for the train set?
No, even for LHB also we do, sir. Yeah.
Achha.
Yeah,
Okay.
always any mission, the field feedback is really gives a good. That is the practical feedback given from the field. Based on that, yes, we have done improvements.
Okay. If you could share something with us, I mean, we'll be happy.
Your good name, sir?
I'm Deputy CME Charbagh Workshop.
Charbagh.
Yes, Charbagh. We are going to do the overhauling of this Train 18 actually.
Oh,
The SS2
right.
set.
Which location, sir?
Lucknow, Charbagh Workshop, Charbagh, Lucknow.
Right, sir. Right, sir. Okay. The overhauling of our train 18 is going to happen in Lucknow only, right, sir?
Yeah, SS2 schedule actually we are planning to, I mean, do, and maybe subsequently we will be doing even the upper gears. Actually, upper gear and all is being done at the Sakur Basti diesel set. We are doing only the SS2, but with the development of the infrastructure facilities at Lucknow itself, probably some more activities will be done by the Charbagh shop only. I mean, apart from the routine maintenance that will continue with the Sakur Basti set.
Sure, sir. Definitely, we will submit needed manuals and all well in advance during the supply of the unit. And definitely, we will be in touch with all the workshops, sir, and any and we'll take keep continue taking the feedback. Yes, sir. Can we move on to the last slide?
Yes.
So this about the driver cab unit, even though it is a small capacity, our pilot also important. Yes, we are providing a driver cab unit. This is 2 TR capacity and heating of 2 kilowatt. A brief of the dimension 1.1 and 1 and 0.5 meters. Structure of SS, airflow of 1000 cmh. Again here are 4070 refrigerant. Initially, I was asked like, what is the combination of R407C. This is hydrofluorocarbons used as refrigerant. It is a zeotropic blend of difluoromethyl, that is R32, R135, and 134E. This is a combination of three refrigerant. Weight of the cab AC is 150 kg, and this is having a fixed speed compressor, operates at 415 volt AC. This is a small brief about cab AC, sir, and that's all about the unit. Any queries, please feel free to ask. And beyond all, my very humble request, I like to save the environment. I would request, since in this platform, many of the senior officers as well as the engineers who is really operating the trains and maintaining the units of HVAC. So I would request, let us not leave any refrigerant outside. We always try to recover the refrigerant, and any support required for recovering the refrigerant, yes, we are there. We can give needed guidance as well as equipments also. So let us not this we will be helping for ourselves by for global warming.
No refrigerant exhaust into the environment. So,
Absolutely, sir. We should not do that.
so when you change the system, like when it completes its codal life, what happens to the refrigerant?
Sir, actually, our Indian government is working, whereas in other countries it is very strict. If any refrigerant is thrown in the atmosphere, they are penalized. So, since in India we don't have the system to recycle, so that is in progress. Still, what happened? Like, okay, if the system is completely gone, if compressor failures, we cannot reuse that refrigerant. That case, there is no other way. Say for example, if we want to change the filter dryer or change any line component, if the system is working okay, so we can recover the refrigerant and again reuse. So there are equipments available. We can recover the refrigerant, recycle, and reuse the same refrigerant. So that if that case we see in cumulative, we could able to save that much of refrigerant as well as the environment. We will not be putting this gas in the atmosphere. It will be in the atmosphere for many years. It is not for 1 or 2 days. That is how the temperatures are going up year by year globally. So even in other countries, Europe and US, they already even these refrigerants are phased out, and there are very stringent norms.
So
No
my
one
question
can.
is that, yeah, like in case of failure of the compressor itself, what you will do with the refrigerant?
Yeah, but in other places, other countries, basically the refrigerant will be recovered and it is given to the manufacturer. It will be collected. In fact, in India, the infrastructure is not there. That is how we are living it outside. But whereas in future, yes, we hope that system will come. We can recover any refrigerant and that will be collected and it can be recycled.
Yeah, it may be recycled or maybe it may be treated so that it may not harm the environment.
Absolutely, absolutely. You are
If
right, sir. Yeah.
recycling is not possible, then it may be treated. I mean, and then discharged to the atmosphere. Number two, you have not told the refrigerant used. If you are using the chlorofluoromethane, I mean this that is something which depletes the ozone layer. So I have really very strong observations how this kind of refrigerants which may be phased out, how these kind of refrigerants are being used.
Yes, sir. Actually, in smaller machines like some other application, even in air conditioner domestic application, say for example, this refrigerant having three blends, out of that R32 is the refrigerant, that is a difluoromethane. So there are systems available. It is having some constraints. The volume of the quantity of the refrigerant should be minimum. It is having some drawbacks of flammable properties. R290 also available. R32 is been already introduced in split air conditioners by a few of the OEMs. So
R32 is okay. I mean, it doesn't have the ozone depletion potential, but I mean, it may be having other drawbacks like inflammable, but not the ozone depletion potential. It's not a potential to not having the potential to ozone depletion. In fact, R32. So I mean, I don't know which kind of refrigerant you are using.
No, no, we are using here R407C. It depends on the volume of the refrigerant, sir. R32 is having its own constraint. Yes, for mobile application like automobiles, cars, and these uh, moving vehicle air conditioners, there are few other refrigerants is under research. It has been tried for a car level, that HF41234Y.
Mm.
So it is also having some limitations. In our unit, it is a 8 TR capacity. The total refrigerant is 13 kg. The
Mm.
new refrigerant is having the flammable property. So, say for example, the volume of 100 grams or 500 grams only is allowed by the standard based on their research, allowed to use in a system. If it is more than that, by any chance, it may get flammable. Fire might happen. So that is how researches keep going on. So we hope soon we will. Uh, there are alternates also in pipeline already in other countries. We are using, and we are also already developing the system. There is a 513 refrigerant.
Mm.
So definitely, yes, over a period of time, we will also come out with the alternate solution.
What is the total capacity of this thing? How many, if you convert into tons of load for every coach?
This is one unit is 8 TR, sir, approximately. So 16 TR is the capacity.
Achha, 1 TOR for one coach.
One coach is 16 TR.
16 TR, 16 ton of refrigeration.
Correct, sir, correct.
Okay, fine. Any idea how much is the electricity consumption for that?
Yes, sir, we have given in the nameplate that is at the rated condition, tested condition, 13.1 kilowatt. So it depends on practically, it depends on the ambient temperature, it depends on the humidity, it will vary, sir.
So 13.1 kilowatt per coach.
Per unit, sir.
Per unit. There is one unit in one unit per coach or 2 units per coach?
2 units per coach, sir.
2 units per coach. Okay, fine. This is
Right.
all from my, this is all which were having my observation. You may please go ahead with anything you are having in your mind.
Yes, sir. Thank you. Thank you for your queries, sir. Like always, questions are most welcomed. That is how we always, in the learning curve always. So whatever feedbacks, please feel free to give us, sir.
Is there any more class after this?
Sorry, sir.
Is there any more class after this in today's program?
Today it is over, sir. If any queries, we can please feel free to ask. Otherwise, we can.
So
Right.
that was the, I mean, the last class for the today. It was the last
Yes.
session, in fact. Okay.
Oh, sorry about that. Yeah, in the schedule, HVAC is the last class today.
हेलो, हाँ रितिका। अच्छा, वो है अभी सीटीओ साहब हैं वहाँ शॉप में?
सर एक्चुअली हम अंदर आके तो वो मीटिंग लेनी थी, तो विशाल से बोल रहे थे कि जब बुलाना होगा तो हमें बुला लेंगे। एक बार कंफर्म कर लेते हैं सर कहाँ पर है।
ठीक है, कंफर्म करके जरा एक मिनट बताओ।
जी सर।